Hello everybody! This is the first of a sequence of 3 tutorials in which we will learn how to make a real application using Signum framework. Our target is to create a client-server solution for a shop, using an n-layer architecture in just 30 minutes. In this tutorial, we will focus on designing the entities, the first and more important step when building an application using Signum framework. We already have lost some time, so let's hurry up. We open Visual Studio and we are going to create a new project.
Now we are going to create a new client-server template project, and the name is going to be shop. Now the template is creating the 6 projects of a typical client-server application. In order to have a bird's eye view of this architecture, let's go to Framework Map in signumframework.com.
We open Internet Explorer, signumframework.com. And here you just go to Map, and we have the image here. I have a shortcut to resize it properly. Let's try to understand this component diagram. Except for the database, every single icon here is a .NET assembly. The ones in silver are Signum framework and are meant to solve technical problems. We won't focus on that here. The other 6 are the assemblies that have been created by the template and that you have to write.
The most basic assembly, sub entities, is where you write your custom entity classes and most of the validation. Nothing else, so it can be shared between the client and the server. Sap Logic is where you put all your business logic processes. It has a dependency to Signum engine and the database, so it can only be used by the server. Sap Load is the console application where you write all the admin tasks like creating the database and moving legacy data. Sap Web is the web application that will run in the server. Its main purpose is to host the WCF service that will be used by the client application. And finally, Sap Windows is our client application, just a WPF user interface that will use Signum services or custom contract to communicate with the server. If you don't need a smart client and you are planning to write just a web application, you won't need all these 4 assemblies. However, if you want my advice, wait for Signum Web to be ready, because it will make much easier to use ASP.NET MVC with Signum framework. So, we close it.
Whoa, we have lost 3 minutes. Let's start writing the entities. Go, go, go.
We remove the example entity, and we are going to create 3 classes.
Order is customer, and the last one is employee. Okay, order is going to be your main entity, and it's going to have a field, datetime, order date, and it's going to have another one, datetime nullable, ship date. Signum framework tries to reduce type mismatch with the database and also has full support for nullable types. And another field of type decimal, that is the total price. An order also has an state. Since the business logic is going to depend on that, the best solution is to write an enum state with the values ordered, paid, and shipped. Then we just have to create a new state field, because enums are completely integrated in the framework. They will even have their own table. An order also has a lot of order lines. They don't need an entity by themselves because they are always going to live inside of an order, so we are going to make it an embedded entity. An entity has a field quantity of type int and also has a product that is another entity. We are going to use entity with name snippet. A product also has a decimal field price, and then just create a reference from the order line to the product. Creating another field, product. Okay, let's take some air, and the final part is to create a list of order lines in the order.
we're going to use mlist, that is just like a list with change tracking. Lines. We close this and let's continue with the employee. It's an entity with name, employee with first name. First name. We don't want the unique index attribute. The custom attributes that are placed over the fields are usually constraints for the database columns, while the attributes over the properties are validators. They are independent things, but using snippets we kept them synchronized. Okay, we have the last name and the date of birth. Here we go. We have to override toString, so we have the first name and the last name in there. ToString value is stored in the database and used for latency, so it appears all around, in lists, combos. It's important to override it properly. Okay, we close this and let's go to the customer. It's a new entity, customer. We have to include this. And it's going to have 3 fields. First one, address. Another one is going to be the phone number. And finally, we're going to have the field email address. Email. Okay, let's add another validator, the email validator, that has the proper regular expression for validating emails. Okay, and here is the important thing. We are going to make customer abstract, so it won't have a table. And there's going to be a company with the company name. And also we are going to create a new entity that is going to be a person with first name. We don't want the unique index also, and another field that is going to be the last name. We also override to a string to have a nice string representation. Also, we make company and person inherit from customer directly instead of entity. And finally, we are going to decorate customer entity with implemented by attribute. This way, the framework knows that whenever we speak about customers, we really mean a person or a company. Of course, there are other ways to include this information without creating a dependency from the interface to the actual implementations. Let's close this and turn back to the order. Now it's time to associate order with an employee. Since order is starting to become quite heavy, we are going to make it a lazy reference, so it won't be retrieved from the database. Employee. Finally, let's create a customer field, so it could have a person or a company. Customer. And that's all. We have finished with our entities on schedule. Let's close this and see our work in a class diagram. We lay out like this. Okay, we have orders associated with a customer that could be a company or a person. An order is also lazy associated with an employee and also has many order lines, each of them referring to a product. Finally, the order has a state that, by the way, have to be synchronized with zipDate. So let's do that using imperative validation capabilities. We override the indexer, saving the base error, and then we test if the column name is the name of the property we are interested, zipDate in this case. In that case, we test, and if zipDate has a value, then the state could not be shipped. And then we create a new error. Oh, we are going to include Signum utilities for this. At line, zipDate has to be null if the state is not shipped. Okay, and otherwise, if zip doesn't has a value, then if the state is shipped, is another error. Error at line, zip needs a value if the state is shipped. Okay, that's it. This is looking amazing. See you in next tutorial.